I did it. I figured out how Construction Master and Build Calc figure out their jacks and why they're wrong. Not by much, but it's enough that they're not true. So I just checked a couple of these. What they do is they've done a wire diagram, and when you enter the calculated run right here, let's just do this whole thing, and I'll show you. So we're going to go 9 feet, 11 inch, 1/4 run, 8 inch pitch. So the rafter is 11, 11 and 5/16. And I guess I could move down here. 11, 11 and 5/16, correct. And the hip, 15, 6 and 7/16, 15, 6, 7. Yep, so both of these are correct. Rafter, hip, correct. And then what I did here was I measured horizontally from this line to this line, which was this value. And then I used that as a run with an 8 and 12 pitch, and it gave me 10 foot 4 and 1/16. So 10 foot 4 and 1/16. So let's see what happens. We're going to go jack, 16 inch on center. That's correct. Increment is 1 foot 7 1/4 or 174. That's correct. First jack, 10, 4 and a 16th, 10, 4 and a 16th, 10, 4 and a 16th. Hit jack again, 8, 8 and 7/8. And the reason why that's a 14 is because it's 14/16, because the last digit in this type of dimensioning is a 16th. It's not reduced to its lowest common denominator. 7, 1. So this would be, excuse me, this would be 7, 1, 10. Got it. And then I need to pull this back up. Hit jack again, 5, 6 and 3/8. So that would be 5, 6, 6. Pull this back. You know, I wish I could pin this to the front. That would be so awesome. 3, 11, 3. I think I fixed the audio. I had OBS recording the audio twice, one through the microphone and then one through the display capture, I think, something like that. But there was a micromillisecond worth of delay in one of the recordings, so it made it sound kind of tinny. 2, 3, 15. I'll know once I'm done recording. And if it's not fixed, you'll never hear me cussing because it won't be recording. Zero, 8, and 11. We're gonna go look at this. I've been trying to figure out how they do this, because I want to understand how they're getting the wrong numbers, and then I'm going to explain why. So anybody who's actually a real framer, when you start putting hand cut roofs together and you're putting your jacks in along your hip, you would use, this is to the face of the ridge. Like if this whole thing was 20 feet, then the half span would be 10 feet. And we're using 1.5 inch ridge, 1.5 inch hip. So you take off 3/4. And that's what I did. I made this box 9 foot 11 1/4. And then I just ran a 45-degree single line all the way back here. Single line right here represents a common rafter. And this represents a common rafter from this point back. And then I just offset these lines by 16 inches, like that. And these are the horizontal run component from the outside of framing to where it would touch this line. And that's the length you get right there. And then you use that length as your run. Then you put an 8 in the pitch. And then this gives you your diagonals for your rafter lengths. So that's how, as you just saw, Construction Master does the same thing. All you had to enter in was the run, the pitch, and then it goes along here and tells you all kinds of good information. There's your rafter length. There's your hips. And then they make it really easy for you, right? So you just trust it. And you go, okay, well. And then you cut all these. And as you're putting them in, you're noticing that they're just a little bit off. They're short. Or, well, you don't really notice that until, let's do this. Make this 48. Let's see. It won't really be 48 because 48 would be the diagonal. So let's figure out exactly what we're playing with here. If you're looking straight down from the sky and you had 48-inch diagonal, 8-inch pitch, the rise, oh no, the run, I'm sorry, 39 and 15/16. So really, if you look down at a 4-foot sheet, it's 39 and 15/16. Because it's on an 8 and 12 angle, looking straight down, that's how wide the board looks. Now this direction's always going to be 8 feet because you don't lose anything because it's not on an angle in that direction. So let's make this something interesting so we can see it. Let's do a hatch angle 2, no background. Make it 4, make it a little bigger. And this line will make it like there. Okay. Now we're going to do point-to-point move. Let's take this and go point-to-point right to there. So you'd be cutting that little tip off right there. But what I was saying earlier was when you put the plywood on, the jacks, especially as they're getting smaller, start leaning away from the plywood. So you're dead center, 3/4 splitting the jack. And then up here, you're barely catching it. And that has frustrated me since I started in 1989 on what's going on. What are we doing wrong? What's happening? And because when I first started, what they would do is you would get the skeleton up, which was the ridge and the end common, main common. And then you would measure the hip and put it in. Then you would use a string, or some people have calibrated eyes. You would look down this thing, get it straight. And if it had a sag, you'd put a brace under it. Get this as straight as you can. And then off this board or this one, whatever's the straightest and braced, you would pull your tape measure over, make a mark at 16, pull your tape 32, pull your tape 48, and you would mark the hip all the way down. And then you would measure from the wall. And that's another thing. You're hooking on the wall, measuring to the top. So you're going across the board. You're not going along the top of the rafter. When you do it this way, you're actually going from inside the bird's mouth to the top. So that's another weird thing. And that's how we used to do it in the olden days. And then once we figured out, Construction Master came along, and that was the same time I had that HP 48SX. And I thought the Construction Master was pretty awesome, but then I told myself I don't have enough money to buy one of those because I bought this HP. And so I forced myself to learn how to calculate or how to create equations to do all this, because this is just, some of this is Pythagorean and some of this is very easy trig. And the hard part is learning how to program, which is just a sequence of steps. Once I overcame that, I went, oh, dude, this is just linear. This, whatever I would do on paper, I'm just doing those steps in the calculator. And then all I got to do is put in whatever limited variables and then manage them correctly to get the right output. So we evolved. The boss had the construction master, and we were going along, and it just killed me that for some reason I always felt like, how am I getting these off? These should be full sheets here, and then start an angle, and it's always a pain. You're always adding a nailer block to the side somewhere along in here in case it doesn't quite make it to the jack rafter. But that now I know how they got their numbers. The way they did their software, both this hardware here, Construction Master, or this app, Build Calc, they get the exact same numbers. And everything is okay down to the jack increment. And then after that, they're wrong because they're not factoring in the thickness of the hip on the direction that it goes, not an inch and a half this way, so it's 3/4, but actually in the direction of the jack, it's thicker, and your layouts. So this would be like, this wouldn't be a single line. This would be this, right? Let's make it 1.5 inches. Okay, so there's your end. Then this would also be over here. And let's center it on this line. It's not actually centered. No, it should be the face. And then let's put the ridge up there. So now we're starting to build the roof actually as the components are. And then if you were to run this down here, and let's, just to make it easier to see, we'll fill this with gray, like that color gray. Maybe give it 20% transparency and bring it to, let's see, bring it to the front or the back. What do we want to do? Probably send it to the back. Since the plywood would be on top of it. All right, and then we'll take this and we will offset it 16 inch. Now let's just look at these for a minute. I have to turn off the line thickness for a minute. I'll put it back on in a second because I need to see what I'm doing here. This one, boom. This one, boom. Okay. So now that single line theory of 9, 11 1/4 is actually measuring to the short point of the bevel, long point of the angle of the rafter. And that's not how I always cut. I would always grab this long point. So let's see if we can dimension that. What happened? I think when you drop 2 dimensions on each other, I think they die. I don't know. Let's try this again. Go like this. Yep, that's weird. Okay, so let's just dimension it by itself then. So that is the horizontal component from the wall to the long point. And let's get our calculator out and see what that is. Clear. 8 feet. I got to see what that is. 8 foot 8 3/4, right? Of course, I always leave. Hang on. I always leave something highlighted, and then you can't see it because it's got all the grip handles on it. 8 feet, 8 inch, 3/4 run, 8 inch pitch, diagonal, 10 foot 5 and 7/8. So that's what this one should be, 10 foot 5 and 7/8, not 10-4. If I'm correct, let's see. No, that's not correct. You know why that's not correct? Because I don't have 1.5 inches here. So I have to go copy, paste, rotate. I knew that number seemed too big. That's another thing, is always try to think about what you're doing and go, wait a second, is that even possible? All right, so like I said, let's make this one solid gray, the second one over. Hit OK, or it won't let you out of that loop. 20%, boom. Send it back. Okay, so now I can pull this back and measure it. Now we'll be okay. Now let's see what that measurement is. Whoops, see, be careful, man. Don't know what it was snapping to, but it wasn't accurate. Okay, so let's see if we can move this, if it'll let me move it to there. Yes, okay. So this is our run. I'm going to unhighlight that by that. Where is, well, I guess I closed my calculator. So that's CM. Clear this. I wish I could use NumberPad to type these in. That'd be kind of cool. 8'7". I wish I could just touch the screen, actually. But that would be an iPad. So that's not what I have right here in front of me. And 11/16. Run, 8 inch pitch, diagonal. All right, so the real length that you should cut this, not 10'4" and 1/16. It should be 10'4" and 10/16. So it's 9/16 too short if you use a construction master. And I can totally trust this because in CAD, if you draw things to the exact size that they are and space them exactly the way you're going to do it, then when you dimension, the computer tells you what that line is. I'm not creating these numbers out of thin air. This is exactly the run. And so now we just calculated 10'4" and 5/8. And that's what it's supposed to be, 10'4", 10. And that's how I figured it out. So like I've said before, this is a great calculator. This is a great app. This app gives you so much extra information, and you can email it to yourself. It's pretty cool. In fact, let me see if I can, I was better prepared. Let me come over here and find that. Yeah, so here's some Build Calc. This is what it did when it figured out the spacing. Even though it's wrong, it's 10'4" and 1/16. It numbered them. And some of this information is good to know. Maybe not that one so much, but like this one. Check this out. I'm going to bring that to the front. So this one, hip valley, there's angles, talks about the rise, the run. That's the run of the roof. There's the pitch. Here's the rafter, 15, 6, and 7. That's correct. Your plumb cut angle, if you needed to do if you just needed to do that in degrees, sure, no problem. What's cool is this is your hip backing angle. He gives you that. That's really good because what you can do is set your saw to that degree and then drive it along the face, the wide part of the hip, and create a little sloped roof. You're going to hang your saw out far enough that you're going to cut half of the top in one direction and half the other. So when you're done, you have this peak running down the middle of your hip, and it'll be 23.09 degrees on both sides. And then your roof will plane to that perfectly at an 8 and 12. And what's good about doing that is then you don't have to drop your hip. You don't have to cut it. Like the hap on the rafter is 4 3/8, and you would make the same on the hip at the corner, 4 3/8. And I don't see too many people that rip their hips. And you can also do the same with your valleys. You have to set your saw depth so you don't cut too deep. But if you really want to be accurate, like the very next one I'm going to frame, I'm going to do it just to have pictures of how it's done. Sheeting angle, even that's good to know. So I highly recommend BuildCalc. Just don't trust the numbers. What I'm going to do is figure out what you have to, well, I can't. I was going to say I could figure out what you got to do to actually make it generate these correct, but it changes all the time. Each pitch has its own adjustment. And then if you have an irregular roof where it's 2 pitches, one on the end, one on the main side, if it's lower, it's going to have a longer horizontal through the hip or valley, and the end piece, the end side, will have a shorter one if it's steeper, and that will cause you might as well write the software to enter the thickness of the ridge, the thickness of the hip, and it knows that your main pitch is this and your end pitch is this, and then just write all that out one time, and then let the calculator figure out the right answers. So this is what my calculator that I did does, and it's just software. Anybody can buy this calculator. It doesn't come with any of the equations, but you can write them to do whatever you need. And my main common equation gives me my rafter length. It tells me for a 16-inch overhang, there's the tail length. There's a total board to be able to order lumber, 14 feet. And then like on this particular one, it needs a 6-inch scaffold for a 6-foot person. Because I did all my scaffolds are usually at face height, so it's easy to duck under things. And so part of the calculation is you figure out the rise, and then you subtract whatever, like this is the calculated rise, but then add the hap to this to get the top of the ridge. And you want to be able to at least look over the top of the ridge and down the rafter. So that's usually a good height to set it. But I always worked with shorter people, so they ended up making the scaffolds a little higher, so I ended up having to duck a lot. This weird one, I don't even remember what this stands for. CBN. It's like cornice in Memphis. Everybody wanted their reveal of their fascia below the soffit to be 1/2 inch, no longer, no less, because if it's too long, it gets wavy or it cups or whatever. So the framer that I was working with was adamant that all subfascia and everything has to be determined so that when you're done, your finished fascia only sticks down past the soffit 1/2 inch. So I added this to this equation. I've never used it since. Oh, here's a good one. So on the hip, I can lay out the hip because that's easy to figure out. And your first layout right here is 1'10" and 11/16 from the top down. And then you hook onto that and you go 25 point whatever. So 2'1", and just keep plotting that along. And I think what I'm going to do is I'm going to write a step off that uses this more accurate number to do the offset or to do the multiple additions, because 2'1" is 25.0155. If you do that, say 15 times, you'll be off at the end compared to using just straight 25. So that's why I always put in extra long decimal places because if I was stepping this off with an offset in a CAD program, or if I'm adding in that, like in Construction Master, you can take this number, go plus, I think it's plus equals, or it's equals after that, whatever. It'll just add itself to the next total and keep going. You want more detail when you do that. Keeps you more accurate. That's like this jack. It's 19 1/4, but really it's a little bit micro less than 19 1/4. So if you're going to do a bunch of those, try to use this number first because it'll keep you more accurate. So we did it. We know exactly how they did it. They just did a wireframe and they just did their math to do a wireframe. You enter 16" on center. They do the wireframe at 16. You do 24. They do it at 24. The hip is a wire. Everything's a wire. And in their business model, they are happy being close enough. They're 9/16 of an inch off on an 8 12 common roof. And right here, that's nothing. On an 8 foot 7 and 11, and they're 9/16 too short. It's so minimal. Everybody goes, yeah, whatever, no big deal. But down here, these two, you will visually see that they're off. And so that's why I'm writing this book and I'm making these videos to inspire the next nerd framer to dive into understanding exactly what's going on. Write your own equations, because people, they'll put in an LVL right here, and all of a sudden it's thicker, and so that means your jacks are different. And actually, an LVL would help with the Construction Master because that little thickness that it kicks out will be taken up by each jack being a little short, and so it'll actually straighten them out a little bit. So that's good. But I don't know, what if your ridge was thick and you did your calculation to the face of the ridge? Then you got to come over here and go, okay, well, how thick is this? Okay, well, then I need to redo this calculation here to factor in how thick this is so that the number I use over here, the new number, not to the face of the big fat ridge, but this new arbitrary number that's a little, like more like a conventional ridge, will give me accurate jack numbers. And that's another thing I'll have to play with. I'm sure some of you guys already figured that out that are Construction Master gurus. So I'm willing to share everything I got and everything I know, but it's a two-way street. So you smart guys, put some stuff in the comments and let's build this into a kick-ass nerdy framer video link place. I don't know. All right, enough of this. I'm going to put this one up right now.